3 agents started from the same empty Blender file. Each delivered a working miniature factory, a conveyor, colored cargo, a robot arm, bins, lights, a camera, and animation. And all 3 satisfied every machine-checked artifact requirement. But they did not take the same route, finish in the same time, or produce the same visual result. Their audited scores were 96, 93, and 88 out of 100. Those numbers are not a universal ranking. They describe one task and one run for each model plus provider combination. The useful story is not simply who scored more, it is what happened between the empty scene and these 3 finished frames, and why independent checks changed how the runs should be read. Hermes Agent is the shared orchestration harness. It gives a language model a task, manages the run, and exposes approved tools. Here, the tool was Blender MCP, a model context protocol connection that lets the agent inspect and operate Blender through structured calls, including running Blender Python. So the model supplied decisions and code. Hermes managed the interaction, and Blender created the actual scene. Only then do the benchmark conditions matter. Every scored run received the same frozen task prompt and the same empty baseline file, with no external assets. Each had 45 minutes, no more than 40 Blender MCP calls, and no human repair after the start. The required delivery included a 1280 by 720 PNG, a saved Blender file named Objects and Materials, and Animation. The models and providers differed, so their internal execution was not identical. A planned Laguna S 2.1 local take was excluded before scoring and has no result here. The first card is the exact deployment label, openai-codex GPT-5.6 Sol. It finished in 5 minutes, 28 seconds, using 13 audited Blender MCP calls and built a scene with 102 objects. During construction, it repaired its handling of Blender 5.2's layered action API. It then made 2 visual remediation passes, including work on the red cargo's visibility. The independent score was 50 out of 50 for deterministic checks, 36 out of 40 for visual review, and 10 out of 10 for process evidence, 96 overall. The frame was detailed, but not flawless. Reviewers noted a cropped gantry, visual weight concentrated in the upper left, and weak separation among dark materials. Next, Anthropic, Claude Opus 5. Its first Blender Python call failed with an attribute error. The agent diagnosed the problem, repaired the call, and completed the factory in 11 minutes, 46 seconds. The final scene had 28 objects. Independent QA awarded 50 out of 50 deterministic, 34 visual, and 9 process points for 93 overall. Its sorting story was especially clear. The red cargo visibly belonged in the right bin. The trade-off was a simpler primitive finish, similar grey materials, and unused space in the upper background. Keep the reporting layers separate. The agent's own report said 12 calls. The raw log audit counted 14 Blender MCP start events. The score uses the independent audit, not the self-report. The third deployment was openrouter, moonshotai, Kimi K3. In this run, about 15 minutes and 23 seconds passed before the first Blender call. That is an observed stall in this provider and run combination, not a universal claim about Kimi latency. Once tool use began, the agent recovered and completed the task. Total runtime was 32 minutes, 4 seconds, with 66 scene objects. Independent QA found 26 calls and scored the result 50 deterministic, 29 visual, and 9 process, 88 overall. The final frame met the artifact contract but showed more basic primitive detail, a cropped right bin, overlap between the robot and yellow cargo, and flatter lighting. Again, self-report and audit differ. The report said 16 calls. The raw start event count was 26. Mechanically, this comparison produced a three-way tie, 50 out of 50. Each Blender file opened. Each final PNG was valid at 1280 by 720. The required object and material names existed. Cargo used the matching color materials. Camera, frame range, and frame rate matched the contract. Red Cargo had the required keyed movement and lift, and at least one robot arm object carried animation data. This validator answers an important but narrow question. Did the delivered artifact satisfy the measurable contract? It does not decide whether the composition is balanced, the materials separate cleanly, or the sorting story reads instantly. That is why deterministic completion remained separate from human visual review. Now, the outcome cards can be read in context. In this single fixed task, GPT was fastest, used the fewest audited calls, created the most objects, and received the strongest visual score. Opus took a little more than twice as long, but made the sorting relationship particularly legible and recovered cleanly from its first call error. Kimi took the longest, nearly 6 times GPT's runtime, and used the most audited calls, yet still recovered within both limits and delivered every required artifact. The final totals, 96, 93, and 88, were separated by visual finish and process evidence, not by missing files or broken mechanical requirements. The lesson is not a universal model ranking. It is that a shared harness makes trajectories comparable, while separate evidence layers make the conclusion trustworthy. An agent can say it succeeded. A raw audit can count what it actually did. A validator can inspect the saved artifact. And a human visual review can judge what checkboxes cannot: clarity, composition, detail, color, and polish. For this one factory task, all 3 agents reached mechanical completion, but they reached it through different failures, delays, repairs, and finishing choices. So, when an agent's final message says "done," treat that as the beginning of verification, not the end. Completion should mean a real artifact, independently checked, with visible quality evaluated on its own terms.